right? That's your doors. You want people to come in, but unfortunately, or fortunately, depending on how you look at it, people can't just walk through your walls. I mean, that would be kind of cool if you could walk through walls, but. All right. Let's talk about the structure of the plasma membrane. The plasma membrane is composed of what we call a phospholipid bilayer. What is a lipid again? Fats and oils. And we spoke about the structure of the lipids, and we spoke about that lipids are normally one molecule of glycerol attached to three what? Do you guys remember? Fatty acids, correct. But the phospholipid is a little different in that it's a lipid with a phosphate group attached. So instead of 3 fatty acids, you have 2 fatty acids, and you can see that here. And here we have a phosphate group that's attached. So it only has 2 fatty acid tails, and it forms kind of like a sandwich. So you have one layer at the top, one layer at the bottom, and the phosphate groups forms these polar heads. What does polar mean again? Okay, water was polar, and it had some of those features. Now, does it mix with water or not?
No.
Polar.
Yes.
Yes or no?
Yes.
Yes, polar mixes with water, non-polar mixes with, does not mix with water. Good job, it mixes with non-water. All right, so is oil polar or non-polar? Non-polar. Is salt polar or non-polar? Salt?
Polar. Oh, okay. It's salt, yeah.
So what is it? Okay, so salt is polar, right? Next question. Does soap mix with oil?
No.
And dirt and that type of stuff?
Yeah.
So you guys asked the question, which one of you are right? Both of you are. Soap is kind of like a, not a phospholipid, but it's kind of like it in that it has a polar part and it has a non-polar part, which is good, right? Because you want it to mix with water, and you also want it to mix with dirt and oil and all that stuff, right? So that when you take a shower, you get rid of all the dirt and the oil and all that stuff. Does that make sense?
Is it like soap? Doesn't soap have like fat?
It has oil in it. Well, it depends on the type of soap.
I thought they make soap out of like actual fat.
That's what I've heard.
Yeah. I don't know about that. But yes, that is true. Some of it is made out of that. Some of it is made out of different things. And all right, so we have a phosphate group forming a polar head, which is what we see here. And then we have the fatty acids and the fatty acid tails forming the non-polar tails in the center, which is good, right? Because is there water inside the cell? Yes. Is there water outside the cell? Yes, there's water all around the cell, water in the cell, so you want the polar heads to be on the outer ends so that it can be exposed to the water on both sides. Let's talk a little more about the structure of the membrane, and what we're going to talk about is called the fluid mosaic model. What does fluid mean? Liquid, right? It flows. What does mosaic mean? What kind of a picture?
Like a mixed up picture.
It's like those pictures where you have like a bunch of smaller pieces that come together, right? To form something, to form a large picture.
Yeah, like a puzzle. He said it, not me.
Not really like a puzzle, but kind of. But it's not in any specific way that you could put one piece with another. But you take individual things, put them together, and you form a bigger thingy. Except for if you're thinking about a mosaic picture, it's usually a bunch of smaller pictures. Yeah, and that you guys know what I'm talking about, right? So that's a concept we're dealing with when we're dealing with mosaic. You have a bunch of little particles that come together to form a bigger overall picture. So let's talk about the fluid mosaic model and why we use this model to describe the plasma membrane. The membrane is fluid. Why is it fluid? Because we have